Hi everyone, I'm Will Sargent. I have been working on this code for about 2 years now, and it is called Debugging and Observing Your Scala code. I practiced for this by inserting many bugs and observing many Scala codes, and have been working on this talk for about 2 years, so it's going to be a high-level overview. Questions at the end are going to be welcome, yeah, I'm just going to dive straight into it. So I'm Will Sargent. I have a Twitter, I have a blog. I talk about logging a lot on both of those, and about debugging and about other interesting things. You can get more detail if you follow those links. And the problem is, well, let's give a context for the problem. You're running services, you're running them in the cloud, on AWS or on Google Cloud Platform, and suddenly a wild exception appears. And it only shows up in production. You can't reproduce it locally, or you can't reproduce it in staging. What do? You can observe it. There is actually an observing system that allows you to see that there is the exception. But the overall health of the system is fine, and it doesn't care. You can't attach a debugger to it because it's in production, and you don't know where it's going to happen beforehand. And you're not really in a position where you can really figure out how this exception came to be. In addition to that, observability has another problem, which is it only observes things that's actually happened. It doesn't observe things that haven't happened. It has a hard time with non-events. So if you have emails that don't get sent, or you have data that doesn't get written to a database, observability has no way of really tracking that. Unless it's an expectation that's explicitly saying this is some number less than what we expected in aggregate, then great. But if it's only happening to very specific people, or if it's only happening in various particular edge cases, observability isn't going to track that for you. And the reason why is because these are systems that are fundamentally set up for operations. They are telescopes, they look at the whole picture. They don't look at the fine-grained details. And what developers really need is microscopes. So we're in the position of looking for needles in very large haystacks. It's not just one haystack anymore. We've got multiple microservices all passing data around to each other, and we don't know exactly which haystack to even look at. Distributed tracing is supposed to be a solution to this problem, but the problem with distributed tracing is A, it's sampled. B, when it is sampled, it's on the trace and not actually on the span. So it always gives you the same amount of span detail. And it assumes that what comes in on a request and what comes out is everything that's important to the application. It has a hard time dealing with already existing state. It has a hard time with stuff that's actually built up, and especially state over multiple operations where you have something that's, essentially triggers an avalanche of data in response to multiple small things happening. That is something that distributed tracing doesn't really cover that well. And you ask developers what they want, and the answer is println. Printlns and printf debugging is basically the go-to answer for developers. Whenever there are bugs locally on your machine, that's what you reach for. Whenever there's something that doesn't work, you only start using a debugger or a profiler or BPF, etc., when everything that you think about your println statements have been violated. And in fact, they've done studies and they found this isn't just an individual thing. Debugging and even when software engineers are placed into production environments and distributed systems, they immediately go to printlns, they immediately go to the logs, they immediately start looking for debugging in the context of, I expected this state, but it was actually this state. Let me see a journal over time and let me see where this expectation was violated. But of course, we can't have debug logging in production because debug logging in production is just super expensive. And turning on debug logging is a way to get overwhelmed with data. And this isn't true. This is totally not true. The reality is that logging itself is really cheap. It's the observation of logging inside of the systems that are set up for operations and for the overall health of the system that are expensive. And I can actually prove this line by line. And I've done the benchmarks to actually go through how much logging costs in CPU, how much logging costs in memory. The CPU overhead's trivial. Disk storage, if you're debugging, you don't actually care about keeping diagnostic logs for weeks on end. You're not blocking a thread because async appenders have been around since 2012, LMAX disruptor. The I/O bandwidth is really not a problem on today's machines. And allocation pressure, it used to be more of a concern, especially in like 1.8 and earlier JVMs. But the new JVMs, Shenandoah and ZGC, they just make this a non-issue. You just don't see that anymore. And you can click on those links afterwards, like I'll put the slides up. So the thing is that observation, taking all of that log data, sending it off the machine so it can be centralized, sending it through Amazon Kinesis Firehose or Kafka or PubSub, routing it, parsing it, indexing it, visualizing it, all of that stuff. Oh, and like sending it all to Splunk or Datadog or Honeycomb, all of that stuff is expensive. And that's, I think, really where the dichotomy comes in, is as developers, you don't actually want all of that data. You only want the data that you actually care about, that actually has the bug in it. And so what we need fundamentally in terms of debugging and observing your Scala code is debugging that scales down as well as up, where you don't have to actually have all of this distributed tracing and Jaeger and open telemetry collectors, et cetera, in order to be able to debug a problem. You want something that works on your laptop. You want something that can be deployed to production. You want something that doesn't interfere with production once you've got it, and is available, but is not necessarily turned on. And that means that we write structured logging to JSON. You write to a memory mapped SQLite file in Blacklight. Blacklight's an appender which just writes out from logback to an SQLite file. You can turn on Lightstream, which is an SQLite replication facility to S3. And then you can pull that SQLite file from S3, attach it using JupyterLab, because JupyterLab supports SQLite, and then you can do data science to it. So all of the stuff that you see in Databricks, all of the stuff that you see that works with just random globs of JSON data, is stuff that you can do with your debugging just by pulling it. And you can pull a lot of data this way when you need to, and when you don't need to, you can turn all of it off again. And you can do all of that in production. So, all right, that's fine as long as you've actually written logging statements, right? So what happens if you've got a bug, say in Hibernate or in Acker, et cetera? You've got a third-party system that doesn't have logging where you actually want to be able to see it. Well, that's no problem, because we can actually inject logging into any particular class, even if we don't own it, and then be able to get traces out that way. And then once we've actually got this, the question is, okay, well, you've got an exception, but how do you actually make sure that all of the debugging statements that you put into this database have anything to do with the exception you got? And well, we can actually automate this, because we've got a database that contains a journal debugging of all of our past state. We can actually query that database, and then we can use it to indicate that there's been a problem. We can send an error via Sentry or Airbreak, etc. And we can actually send those logs as breadcrumbs to error reporting using the correlation ID. And this is all done using a suite of utilities that I've put together in Logback. Things that just put together the instrumentation. Turns out relative nanos, unique ID, correlation ID. The relative nanos and unique ID happen because when we are logging to SQLite, it's happening so fast, it's actually below millisecond resolution. So we have to make sure that we have unique IDs because we get a lot of milliseconds that are actually exactly the same. And I can actually demo this right here and now. So here we have an app running on Heroku. And I can actually click on this link to render it normally. Okay, and here is the source code for that. Just renders that guy. So this is a normal request. And this is a flaky request that, you know, if the time is over milliseconds, then we throw in a legal state exception. And then something bad happens. So we'll click this guy. Exception happens. And then we click this to see the request, which shows the correlation ID with the message that we have. So we can immediately see this is debug, this is trace. This is all happening internal to the application. But we can also see, let's undo this. So we've got honeycomb here. We can run the last 10 minutes and we can actually see the expanded data showing us we're about to render this. This shows an exception. Here's all of this stuff. So it sends it to Sentry and it also sends it to Honeycomb automatically. And then we also want to just see all of the logs. So these are all of the logs and we'll go through. It blanks out after a while. So we'll render and look at logs. And you can just see we've got correlation ID here. And we've got normal request here. So you can see there's no trick to this. There's just the logs. There's just a background. And there's just the data. So the interesting thing about this is that because this is using terse logback, because this is using logback, in order to get data into the system, we actually have to stick logging with the correlation ID. Well, the correlation ID isn't in here, but usually when you have to do debugging with JSON, you have to actually stick that in manually. And the reason why is because the SLF4J API predates structured logging. Structured logging came in at around 2006, and around 2011 is when it started to get more popular. And log/logback encoder, which is what I'm using for all of the JSON serialization and logging, is 2013. So by the time people really started using and getting acclimated to the idea of sticking login statements in and using logger.debug in all of their Java code, the structured logging and the idea of using semi-structured data had already, it was already too late for it to actually come in. And the result is that you end up with something like this. You end up with log stash markers, append correlation ID. This is very verbose. You have a thread local MDC here, and this is tied to string. You can't put anything more complicated in it. If you're doing any kind of conditional logic and you have a marker associated with it, you should really pass the marker in as well. And that's not an option, and to just sort of have it work. And then the same thing here is you've got to pass the marker in here. You're passing in an argument. This calls person.toString. If this isn't a case class, it's not going to be very useful to you. And then you've just got like silly things like if you've got an argument, but it's actually an exception here, this will actually eat it and you won't see a stack trace at all. So I wanted to make this easier because we've got Scala. We can actually do a lot of things that aren't available with the Java API. And I wanted something that really kind of made it very easy to do the right thing and would try to preclude you from doing the wrong thing. So I came up with Blindsight. And Blindsight has a lot of options to make debugging easier and to solve the problem of debugging stuff in production. And I'll just go through it one by one, and I'll actually do little demos of these in addition to the slides so that you have an idea of what this actually looks like and what this runs and how this comes out. So the URL here is github.com/systems Blindsight starter. So everything I'm running is going to be available to you at home, and you can follow along. And so the first thing is we've got DSL and type classes. And here, when you log an info statement in Blindsight, it looks like SLF4J, but this person here has to be an argument. And if it's not an argument, it won't compile. And so what this means is that we have something that will add a type class and say, all right, we're just going to convert this here. And then we have a DSL, which takes elements of the person and it ties it to key value attributes. And if you've seen JSON4S, this is going to look very familiar. And I am just going to go to the code. And this is the Blindsight starter. And let's see, let's run this. So this is an SLF4J statement, and you can see that this is just running normally. This here is the person, and you can see that the person to argument here just comes up and slots in very nicely. And then you've got a simple example here where it shows you, here's a person, we're going to send it in. If we send something in that's just a string or an unknown value, like a future successful, that's actually not going to compile because it doesn't have an argument mapping for it. And so we can go ahead and run this simple example. And you can see that immediately we are logging stuff as lines here on the front end, but it's also going to a database on the back end. The database on the back end, because it's SQLite, we can do queries here, and we can just see these statements. And of course, because SQLite has a full JSON API, you can do queries that not only say, I want to filter out only things with this level or things by, things by this time, but you can actually query into the JSON as well and be able to select only the statements that you want. So you're not getting overwhelmed by detail. And yeah, one of the interesting things here is that logger.debug, this is not actually calling a method. This is actually a class which is called a method. And so we are calling the apply here, and we're only calling the apply if logging debug is true. So automatically in Blindsight, everything is conditional already. You'll never get a statement called, whether it's using a block or using a regular parentheses that shows up when you didn't want it to be called. Yeah, so that's DSL and type classes. And then we build up context by passing in state through the logger. So here we've got the same sort of thing. We've got a key and we've got a value and we've got the DSL handling into it. And what this does is it prints out to JSON with correlation ID. You won't see this in the line oriented format. You'll only see this inside the database or inside the JSON file. We've got conditional logging. Conditional logging is the same sort of thing where you actually say we've got a logger, but instead of actually like relying on logback and the log level, we're going to say, we're going to have a method that we call, and this method is going to be run every single debug statement, and this only logs when it's true. And you can have that either on the logger using with condition, or you can have it on the statement itself. So if there's additional stuff that you want, they all go together in a logical AND. And so you need all of these conditions to be true. And it turns out that conditions are really powerful. And there's a lot you can say about conditions. But the interesting thing about logging is that because all of the logging statements that you put in your application are controlled by you, if you have control over when and where those logging statements show up, you have way more flexibility than if you're trying to use logback markers and if you're trying to use log levels, because logback doesn't understand and doesn't know what to do with those log statements, whereas you understand in your code, because you own it, that you can turn stuff on and you can turn stuff off anytime you feel like it. And in fact, Microsoft, this really shows up in this case study of logging telemetry, is whenever they had a problem, they would turn on and turn off various different parts of their system to be able to get data and be able to take the hit for like 5-10 minutes or so, and then turn it off again. And to that end, there is a focus in a lot of the documentation to get conditions as powerful as possible. So one of the things that you can do with conditions is you can tie them to feature flags. So if you've got launch darkly running, for example, or config-cat, you can tie a condition to a feature flag and say, I want this to run only when this particular feature is active. You can tie that feature, in launch darkly at least, you can tie that feature flag to a particular user or to a particular HTTP session and say, I only want this information to have all of the tracing or, excessive amounts of detail on it. And that can really help narrow down exactly what's going on, because you have targeted diagnostic logging that can actually show up, can actually be integrated with operations. So it can actually show up in your observability stack if you feel like it, but it doesn't touch anything else. There's also the opportunity to use tracer bullets. Tracer bullets are something that shows up in the request itself, where you have forced sampling in open telemetry and in open tracing. It's basically a flag that says, for this particular request, turn on everything. And that just gives you a much more detailed look at everything in your system, whether you're explicitly looking for it or not. Likewise, conditions can also be used as circuit breakers. And that means, like, under a circumstance where something would normally log, you can have a circuit breaker trip. For example, if a particular error is spamming too much, and you can use that circuit breaker to limit the amount of spam that you get coming from something that's particularly broken. You can put in a condition by time. So you can say, I don't want to log this at 1 o'clock in the morning, or I do want to log this, but only for the next 10 minutes. And you can also log by script. So that means that rather than having the condition know about the logic internally, the condition can actually get a script from elsewhere. It can get it from a database, it can get it from Reddit. It evaluates it, and then it just checks it to see if that script, the source of that script is invalid, and it needs to go refresh it again because that script is stale. And obviously, like, that brings along some security concerns. So you want to make sure that if you are loading code from scripts, you're not just doing a blind eval. But anyway, the reason I mention this in such depth is because this really matters going in, and this really matters later on. And it also is a setup for a lot of how code should be handled in like using this new paradigm. So source-aware scripts, this is interesting. I can do a demo of this as well. You have a script manager which has the handle. The handle can be to a file or to a database, etc. It doesn't really matter. You've got a script location. The script location, the default here is false. So if it can't compile or evaluate the script, then this is what it's going to return. And when we call location.here, that is going to pass in some source code macros indicating the line, the enclosing method and class, the log level. And so when that script is run, it's going to have all of those things available as parameters. So here we've got a script example. Here I've actually got it coming directly from the code. And here you can see that the script says, if I've got an index of, and it contains the word script example, then return true, otherwise return false. So I can just stick the script in here, and I can actually change this code as I feel like. And let's go ahead and enable the script example. And let's run that. This only logs here if the script example, and then I can just change the code on the fly, run it again, and nothing happens. So source-aware scripts, I think, are really useful. I haven't explored too deeply into them, so I've only kind of scratched the surface of what they can do. But I expect them to be I expect more stuff to come out very shortly. This is another, I already went through this. We've got flow-based logging. Flow-based logging is something that automatically wraps code with enter and exit statements and can show you the arguments. So here you'd get an enter arg1, enter arg2, etc., with the names and values of this and the result. And the interesting thing about this is because it's using an implicit flow behavior, we can actually change that, and we can start using it for tracing. So we can actually start using that for saying how long did this code run, and also, what's the hierarchy? Where did this show up in this other thing? So we can do a limited form of tracing on this, although it's not nearly what you would get out of OpenTelemetry or OpenTracing. And then finally, we've got printlns. And printlns, when you actually come down to what people use, they want to be able to say they've got a state dump, they've got execution tracing, and they've got event reporting. So when you do these surveys, typically people are using printlns to do some very specific things. And we'd like them to be using logger.debug. But more than that, if we're doing very specific things, we don't actually need them to do it. So we've got some macros that say decorate vowels, for example. And you can pass that in and have the valdef come back and say the name is this and the value is this. And what this block does, what this macro does is it decorates the block so that after each val definition, this debugging statement is applied directly afterwards. So when you run this code, and I will just go ahead and take care of that. There we go. So we've got an intention example. This is doing something a little different. This is doing a decorate if. So this takes this if statement, and immediately after each if branch, it says, okay, what's happening. This is the condition, and this shows up as false. This is the condition, and this shows up as true. And so you don't actually need to insert debug statements and debug ifs, etc., all over your code. And you don't need to worry about maintaining this either. You just stick this in. And if you don't feel like it, then you just take it out and you've just got an ordinary branch. And yeah, so this is inspecting vals, inspecting ifs. We've got inspecting fields as well, so you can automatically dump all the public fields along with the names. And yeah, the other question that I haven't really addressed from here is, where do you start? You've got all of this debugging information, and you've got a library that will let you stick in debugging statements wherever you want, and we'll stick them for anything in a particular block of code. But what do you actually do with that? And how does this actually help you solve bugs? So I'm still working on this, obviously, but the best guidance I can give right now is, for libraries, you still want to log them at an info or a 1 level if it's Hibernate, so that, because they are going to instrumentation and they don't have conditional logging on them. So if you stick something that's a trace level on Hibernate, for example, you're going to get all sorts of, SQL parsing and HQL parsing stuff on it that you're not really interested in. You can instrument libraries with ByteBuddy code, but it's going to lack context. It may have MDC on it, it may not. Basically, like, if you can get something out of the library rather than actually touching the library directly, that is usually the best help. You can actually change log levels dynamically using a change log level. That is a class that's in Terse logback. So you don't need to use the JMX configurator or anything. It'll just attach to any code you feel like. But for the most part, you should use conditional logging inside of your application. And even if that conditional logging is condition.always, you may want to change that, because you may find that there's personal information that's being caught up in tracing that security would not like you all the time. Or you may find that even if it's always off, there's a particular case where you might want it turned on. It's just a good habit to get into. And logging application code at a trace level to disable filtering, and then having a script that basically says, we're only interested in these classes or these other classes, that's something that you can change at runtime. So by changing the script, you can change the behavior. And because scripts have access to line level information, you can even go so far as to say, I only want these particular log statements in this particular class to be logged. And you can do that without knowing anything. Like, you can do that, and that's something that logback is not going to give you very easily, and especially with the costs involved in Scala and getting caller information. So one of the things that's really useful for debugging, especially if you don't know exactly why a wild exception appears, is you can put together a box and you can say, okay, if a contract, if a precondition, a postcondition, or an assertion is violated, then you can go and stick you can start a logger which has a conditional which is time boxed, and say, for the next 10 minutes, I want you to run lots of expensive queries, or I want to dump a lot of contextual info. We might be getting errors that are not really all that useful here because we've lost this connection. And so you can actually respond to your own environment and be able to say, we suspect that if we pass something in here, we are likely to get nothing back out, and be able to debug the code that way. And it's not 100%. Like, I'm not going to tell you like this is going to work in all cases, But what we can do is we can start thinking about logging in a different way. So we can start by thinking about when we do debugging, when we're actually adding those println statements, we are adding desire paths. We're adding those roads and those paths that go off the track and that go off to the side. And whenever that happens, that's actually a sign. That's actually something that we should keep around, because that indicates that we have to debug something in that general area. And that's actually useful to the programmer that comes after us. That's useful to the person who's trying to build up his intuition, because they're going to be looking at something and being like, what's the history on this? Where are the marks on this code that indicates like where something was fixed, where something was analyzed? And we can actually do this throughout the code and say, we can figure out at the very least where we have major state transitions, where we have branching points, where processes start, where something comes up that may not be wrong, but it's simply unusual, like something comes in with a value that we didn't expect. And provide all of that information as if we know that there's going to be a bug in that code, even if it doesn't happen. And that just gets us to the point where we can take the haystack and chop it into lots of little pieces and be able to say, this piece looks fine, this piece looks fine, this piece looks fine, this piece looks kind of weird. We should dig deeper in here. And then instead of adding logging debug statements randomly through the code, you're only adding it in this context of the diagnostic logging. So the diagnostic logging you can use in place of comments. I actually think that diagnostic logging is better than comments in ways, because a comment can get out of date and can refer to variables that don't exist, whereas diagnostic logging is always going to be there and it won't compile if you're trying to reference something that doesn't exist. And it's something that you're actually going to see in runtime explaining the thing to you as it goes through. And I think that's actually very useful, because a lot of the time, a lot of problem that I have with like a lot of Scala code is that it's async. It runs off multiple threads, and you can look at the code and still have not any idea what it's actually doing, because the flow looks very different from the code, and there's no way to really reconcile the two. Like you cannot look at the code and run through it and look at the comments and run through it and expect any of that to be in order or for that to form a story. But diagnostic logging is a guide. It's a way to say, let's explain this in words of the programmer. If there were a bug, where would it be? Where would you actually add trails and helpful hints and intuition to the person who's following after you? And there is one place especially where I think that we could use a lot more debugging and a lot more handholding, and that is around asynchronous boundaries. And every time we call a future, that completely messes up the map diagnostic context. We have no way of actually using a stack trace after that point. The only way of knowing what happens after we've thrown something through an asynchronous boundary is to explicitly pass in context and say, this is where it came from. This is what the task is. This is what we're doing here. Godspeed, little traveler. I wish you well on your journey. And if we can get into the habit of doing that, or if we can really start to rethink the way that we use asynchronous boundaries, so that they are not simply just a shot in the dark with some random bundle of instructions tied to a task, then I think that would really make debugging and programming Scala code a lot easier. But that's another talk for another time. But yeah, so the diagnostic logging is better than comments. It's your intuition, it's your guidance, it's a live walkthrough of your code. And it's asking what objects and what states are significant, which is something that a debugger cannot give you. and a profiler cannot give you. Like when a debugger shows you something, it's going to show you everything in the stack. It's going to show you everything in your scope. It's going to show you the method names, and it's going to show you the variable names. But it doesn't show you what you've got in terms of a saga. It doesn't tell you like what the history is. And it doesn't tell you like out of all of these things, what are actually the things that you should be paying attention to, which might be mapped inside of a map, inside of a list, inside of a box, inside of an option somewhere else. And what does that mean? If somebody's looking at the code for the first time, they can't tell you. So you, in fact, are their debugger. So this is what I've got so far. I'm pretty happy with a lot of it. Some of it is not something I would have expected to begin with, but the stuff that I'm working on now is actually taking JSON and moving it a step further. So rather than having just blind JSON, which is nice, but it is semi-structured data, and it also comes with a disturbing lack of type information. If you stick something and you say, this is a timestamp, what format is it? Like JSON can't tell you. There is no timestamp format in JSON. But there is something called JSON LD. And JSON LD has a way of mapping a schema to a particular type and being able to say, when you look at this timestamp, this is actually something that is ISO 8601 formatted, and you can work from that. And what I want to get to in the future, I've already got a JSON LD module in Blindsight, so you can use that straight out of the box. But what I want to do for Scala 3 is I want to take information out of the semantic database or out of Tasty. I want to be able to say, I've got a type. I know that the type is a person with a name and an age. When somebody spits out an age, I want to be able to automatically know that this age has the appropriate int type and be able to unify that. And then after that, when you're actually debugging, when you're actually logging, you're not just logging JSON. You're saying, I've got a person, his name is age, his name is foo, and his age is bar. And then because it's a person, it goes to the person schema that is defined in JSON LD that took its data from the semantic database. And then essentially what you're doing is you've got enough information that you can make a debugger irrelevant. And you can replay that change of state over time with the domain information that you have, knowing that this is a Scala program. And from that point, you can do really interesting things to it because we've already got the data science for this. We've already got Jupyter Lab. We've already got Databricks. We can already process things and look at weird internal stuff to do with data. If we have something that says we've got something added to a list, we've got something removed from a list, here's all the events, and we know the type associated with it. And we can stick that into RDF triples, into a knowledge graph, and we can process it. Then we can actually start doing visualizations straight from logging. And we can actually show elements being added and removed from that list and be able to just have it work. So that is my goal. That is my hope. And I think that it's just coming up on 45 minutes now, so I will wrap things up. There are a couple of good books that I recommend. Why Programs Fail by Andrea Sella and Effective Debugging by DeMillis, I think. Yes, Spinellis. I'm sorry, that's his name. And there's also some useful services that I'd like you to check out. One of them that we saw briefly is Honeycomb. I have talked about them a lot in the blog posts, and they do really good stuff. The nice thing about them is that they have a free tier, so you can use all of that for your development, and you can just throw stuff into a data set and analyze it and do things to it that you wouldn't ordinarily be able to do to a database, and they've already got the visualization sorted out for you. Then we've also got Rookout and Lightrun. These are slightly different. What they do is they allow you to set non-breaking breakpoints in code in production using an agent and let you essentially like inject logging statements into production code so that you can see the variable coming through for anything. And I have not tried these out personally, but I think that this is probably going to be what a lot of people are using in production when you don't have the option to inject logging yourself. Okay, all right, questions? So I am on the private chat.
Hey, Will.
Hello. How do I see the, I have to log into Hopin to actually see the Hop thing.
Nope, we're going to do a couple of questions live.
Okay.
And then the remainder of the questions, yes, you can absolutely go back into Hopin and answer the rest in text at your convenience. So our first question is, does Blindsight have CATS integration?
It does not. So Blindsight is a direct wrapper over SLF4J. It is possible to integrate it into CATS, but for the most part, I've tried to put as few dependencies on it as possible. So there are a couple of tools for CATS, which I think are really useful. Natchez, and there's something called Treelog by Lance Walton, I believe, which is also very useful for getting data out. Other than that, I think that when it comes to logging, it is usually logging is a side effect of the system rather than a direct effect. So usually it's something that goes into a tap or a wiretap rather than being applied directly as a tackless final effect. But I mean, obviously that changes when you have context that you need to pass along, and it's very different for tracing. Blindsight's performance is, well, traditional Java logging. So I went through this in some of the blog posts, but basically it adds between 20 nanoseconds and 100 nanoseconds. It is a very thin wrapper that essentially just calls a couple of method calls on top and rearranges things. In addition, because it's using conditional logging in a lot of places, because calling a predicate is 1 nanosecond, if something isn't available and something isn't run, then it actually ends up being a lot faster than if you would call SLF4J with something that does string addition on it, because it's not actually doing that to begin with. So the answer is it's just as fast, if not faster. The other interesting thing is just a matter of context. If you are creating a new byte array with no elements in it, like literally called new array byte, that actually takes 20 nanoseconds. So the JVM, because it has to set up some internal data structures for any object instantiation at all, if you are doing some code, if you are calling some methods, but you're not actually instantiating any object, you can do that 20 times and still end up ahead. So yeah, there's some unexpected stuff in there once you get really down to the basics.
Great, thank you. I think we might have time for one more question live. And it is, can we already use Blindsight in Scala 3 projects? If not, do you plan to make it compatible anytime soon?
Yes, in fact, this is what I was kind of hoping I could do, like just before Scala 3 came out. There are no huge barriers to using it in Scala 3, except for one thing, which is that there is a statement interpolation, which allows you to essentially, like, you use S quotes to actually do string interpolation. Blindsight has statement interpolation, and that does use a string context, which is based around macros. Obviously, all the stuff which is println intentions is explicitly macros, and all of that has to be rewritten for Scala 3. But other than that, I don't anticipate any problems. It does have some Scala 2.11, 2.12, 2.13 cross-compilation in it, but obviously I can extract the code which is not working for that and then isolate it in its own version-specific directories, I hope.
All right. Well, thank you. Thank you for taking the time to answer some of the questions live. Like we mentioned earlier, there are some more in the stage Q&A area. So if you want to take a look and reply in text where you can, that would be absolutely amazing.
Okay, so
But thank you so much for being here, Will.
thank you.
It's now time for today's keynote presentation. We're happy to introduce Felina Hermans, an associate professor who is passionate about programming education. Today, Felina is talking to us about how to read complex code.